All right, so you have a permutation and you need to do algebra with it. You can't leave it as a permutation. You need to turn it into factorials so you have some ability to manipulate it. And the formula that we show you looks like this. NPR equals n factorial over n minus r factorial. I've always read that as a factorial equals the left number factorial over left minus right factorial. That's what we're going to need here. This permutation is the left number factorial over the left number minus the right number. That's a total of n minus 3 after you subtract factorial. Sorry, that should be a 3. And that has to equal 90. Remember when we practiced simplifying factorials and perhaps you wondered when we were going to use that? Here's when we use that. We need to be able to cancel these factorials, and that means we go after the big one here, n minus 1, and we're going to peel some numbers off of it. N minus 1 factorial is n minus 1. We'll also peel off n minus 2. And that leaves us with n minus 3 and everything from there down to 1, which we write n minus 3 factorial all over n minus 3 factorial equals 90. The n minus 3 factorials cancel out. And we get, let's see, what is this? N squared minus 3n plus 2 equals 90. It's a quadratic, of course. So n squared minus 3n minus 88 equals 0. Now, how do we make 88? 1 times 88, 2 times 44, 3 doesn't go. 4 times 22, that doesn't add up to negative 3 no matter how I do it. This may be a problem. 8 times 11, there we are. This is n plus 8, n minus 11 equals 0. So we get two solutions. Or do we? Should we get two solutions? The catch is you can't do a permutation of a negative number. You can't say here's negative 8 things, select 2 of them. So this negative answer gets rejected. It solved the quadratic, but it isn't valid as an entry in a permutation, so we just keep the 11. And the original expression must have been, let's see, 11 minus 1, so 10p2 equals 90. And the n value that they were talking about all along was n equals 11. Okay, some easy permutations to get us started. We've seen that if you have n different things and you have to put them all in order and you have to use every one of them, then there's n factorial ways to do that. So Regina, 1, 2, 3, 4, 5, 6 different letters. That means there should be 6 factorial different ways to arrange that. Now, you can show that that's right. Think about before we knew factorials. If we said, take these 6 letters and put them in order, you would have said, okay, I have 6 choices in this first space, and now I only have 5 choices left, and now I only have 4 left, and 3, and 2, and 1. That's exactly what 6 factorial means. So we were doing questions like this before we even knew factorials, but now we can do them much more efficiently. 6 factorial there, which if memory serves is 720. And Kelowna, 1, 2, 3, 4, 5, 6, 7. So there are 7 factorial ways to arrange those letters. 7 factorial is 5040, I believe. Remember, that will only work as long as these are all different letters. As soon as we start getting duplicates, if instead of Kelowna we give you something like banana, where the same letters appear more than once, there's a little correction we're going to need to make, and we'll talk about that quite soon. More simplifying factorials, but no variables this time, just numbers, so these are a cakewalk. We have 43 factorial over 40 factorial. Let's see if we can break down the big one in some useful way. 43 factorial means 43 times 42 times 41 times 40 times 39 times da 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 da, all the way down to 1. In other words, we could peel off numbers from the beginning of it, the biggest numbers, and we're left with a smaller factorial. For instance, we could say this is 43 times, and then all this stuff makes 42 factorial. You could do that repeatedly and say 43 factorial is, we'll peel off the 43, and we'll peel off the 42, and we'll peel off the 41, and then 40 all the way down to 1 we'll leave in factorial form. And you can see why I'd want to do that, because now our factorials cancel out. So the value of this is 43 times 42 times 41, which I'm not going to attempt in my head. Calculator says it's 7,052. In B, how about that? Okay. In B, if we want to simplify, again, this 37 is the biggest factorial, so let's see if we can get that to cancel against the 33. 37 factorial, we'll leave the denominator alone for the moment, is peel off the 37, and the 36, and the 35, and the 34, and then we'll leave 33 and everything below it in the factorial. That helps because these 33 factorials cancel. And our result now is, again, I go to the calculator, 37 times 36 times 35 times 34 divided by, and 4 factorial is 24. Overall, 66,045.